Hi, I'm Travis Connor, and this is my Physics 2212 Lab 3 about circuits. So as an introduction to this lab, so in this lab, the purpose was to use the principles of energy conservation and current conservation to predict the behavior of circuits containing resistors in series and parallel, use multimeters to measure the actual values of conventional current and potential differences in the circuits, and examine the behavior of ohmic resistors and capacitors. During this lab, the fundamentals used were Kirchhoff's voltage law, Kirchhoff's current law, Ohm's law, and the RC equation. And also you can see the relationship between a resistor and capacitor on the right-hand side of the screen. So the main results of the lab were that the potential difference across a complete circuit was summed to zero. The measured current was 0.016 amps. The RC value was found to be 13.342 seconds. And also increasing the resistance in an RC circuit will increase charging and discharging time. So starting off with the DC circuit experiment, the circuit was constructed using two 1.5 volt batteries, summing to 3 volts, and then also a 47 ohm and a 100 ohm resistor. And so I predicted my current, as you can see, using the following equations, and I predicted it to be 0.02 amps. But actually, after measuring it, I found the value to be 0.16 amps. However, when measured, the actual voltage of the batteries was 2.7, so this 0.16 is, when predicted, is closer to the actual value. And when the connection was reversed, there's a value of negative 0.16 amps, which is consistent with what should be found. And after the conversion to the voltmeter, the ammeter reading was 2 times 10 to the negative 8 amps, which is almost zero, which is what it should be. And the voltmeter reading was 2.8 volts, almost 2.7 volts. Um, the DC circuit continued. So the battery voltage was 2.7 volts. And then the potential difference across the circuit elements was found to be negative 0.59 volts for the 47 ohm resistor. And for the 100 ohm resistor, it's negative 1.8 volts. And across the wires is 0 volts. And across the ammeter, it was also 0 volts. And then when this is put into the formula, you get 2.7 volts minus 0.859 volts minus 1.8 volts, and you get around 0.041 volts, which is almost zero, which is what should be found. The resistance in each circuit element is found with the potential difference over the current. And so the current being 0.16, I did the math of this, and then you got for the 47 ohm resistor, it turns out to be 53.6875 ohms, and for the 100 ohm resistor, it turns out to be 112.5, and then for the wires, there's 2.1 ohms and 6 ohms for the ammeter. Now, moving on to the RC circuit experiment. I constructed a RC circuit with a light bulb to visualize charging and discharging. So during the observation, I observed that the bulb was bright initially and then slowly dimmed as the capacitor charged. When the capacitors discharged, the bulb was briefly bright but then faded quickly as the capacitor discharged. As you can see the measured times. For the 10 ohm, it was much lower than the 20 ohm for both charging and discharging. Here I found the RC value, so I used the equation from earlier and then derived a expression for the RC value. And then the change of potential difference, what was 38% of its initial value. And so I found the RC charging, RC discharging for the 10 ohm resistor, and then found the average values, and I got a 13.342 value. Some assumptions and possible errors in this lab were that the circuit was ideal and in a steady state. This was so that the Ohm's and Node's laws could be applied. Some possible errors were that the circuit was not new and therefore some of the voltage from the battery was lower than expected, such as the battery actual value being 2.7 volts. Also, the timing the capacitor charge and discharge was imperfect. And to answer the what if question, in a real circuit, if there is no resistor, the wires as well as the battery would have internal resistance stopping the capacitor from charging instantly. If this were an ideal circuit model with absolutely no resistance, then the capacitor would charge instantly. This would not happen in real life because there's always some sort of resistance.